Okay, this is Mr. Tallboom, and I am going to show you a presentation on bullet and cartridge comparisons. It's my first time using this, so I've got my giant mouse pointer to point to things I want, and I can hopefully draw on stuff if I remember how to do that. So, bullet and cartridge comparisons. Here we go. First thing you got to know is the different parts of a cartridge. The bullet, which you'll often hear referred to, is just this little part here right at the top. So this thing that fits into the cartridge casing, it's gray in this picture, that's the bullet. This here is brass covered, that's the bullet. Sometimes it'll be made out of lead, sometimes it'll be made out of brass with lead in the middle. It can have different shapes, but only this little part here and this little part here are technically the bullet. The casing refers to this outer shell, which is usually made out of brass. So this is the casing here on the outside. This is the cartridge case here on the outside of this bullet. The powder refers to the propellant, the gunpowder or the black powder that's actually inside there that makes the bullet, which is this part, travel out of the gun. So as you can see, you've got powder filling this up and you got powder inside here filling this up. These are cutaways. You wouldn't be able to see the powder normally inside a bullet. And then you've got primer. The primer is a piece all the way at the bottom right here that's friction sensitive, so that when the back of this cartridge is struck, the primer will ignite and cause the powder to burn. This is a rimfire cartridge. It's got primer all around the inside here. All right, and then when that rim gets crimped, when it gets hit, it'll cause the actual cartridge to fire. Moving on, so we need to go through what happens when a bullet is fired. So let's start not even on this diagram. Let's start with the trigger pull. So the trigger is pulled. The trigger releases the firing pin, which is already cocked back, and it's usually has a spring here to make it go forward. The firing pin travels forward through the bolt, and it strikes the back of the cartridge. It strikes it here where the primer is. That primer ignites, burns the powder that's inside here and causes a lot of pressure right up here inside the chamber. The pressure from the escaping gases causes the bullet, once again this part, to be pushed out of the barrel. As it's pushed out of the barrel, you notice how it's got these lines. This is like a corkscrew type pattern actually cut into it, and that causes the bullet to spin. This pattern is called rifling, the idea of cutting like the threads of a screw inside a barrel. So once again, you go from the trigger to the firing pin strikes the primer ignites the powder inside the cartridge casing. The powder burns, causes a lot of gas to be formed. The gas pushes the bullet out of the chamber into the barrel, pushes it all the way out of the barrel, spinning it at an incredibly high rate of speed. Some things that you should know, some terms that we're going to use. Rifling, I mentioned it already, but rifling refers to cutting grooves on the inside of a barrel to cause a bullet to spin as it leaves. The bore is the inside of a barrel. So if you were to look at, you can see me on this webcam, if you were to look right down the barrel and measure how big it is inside the barrel, that would be the bore. The lands are the raised sections on the inside, and the grooves are the sections that are cut into the barrel. So if let's practice drawing stuff. So if we're staring down the barrel of a gun, doesn't want to work for us. Look at that. Bummer. Oh well, guess there'll be no drawing. So if we're staring down into a gun, the parts that were taken away, those are the grooves. So that's what was cut out of the barrel. And the parts that are still raised, those are the lands on the inside of the barrel. Caliber refers to the size of the bullet that actually fits inside that barrel. So a large caliber means it has a very large bore. A small caliber is a small bore. Bigger the caliber, bigger the cartridge, the bigger the barrel has to be. Okay, so there's a bunch of ways of cutting these grooves into a rifled barrel. We didn't always have rifled barrels. There used to be muskets, and much more inaccurate when you're actually firing things with a musket. You don't necessarily know where it's going to go, where it's going to hit your target. This is why you had, during those Revolutionary War scenes and things like that, you see people lining up to shoot at each other because you didn't necessarily know that you're going to hit the broadside of a barn. The first way we used to cut grooves into a barrel was the hook cutter method. And it would cut a few grooves at a time, and it was a hook like this, and you would actually put that inside the barrel and twist as you went in, and it would cut all the way down. Then you'd twist it out. It made unique rifled barrels. The amount of twists your barrel had depended on how the guy cutting it cut it. So it wasn't the greatest method, but it was better than nothing. The broach cutter. The broach was a device that actually spins into the barrel and cuts away the sides of the barrel as it goes in. The broach cutter is popular if you've actually got a machine shop and you have the tools to create a barrel using this way. So obviously it wasn't too big pre-industrialized America. The button was a cheaper and faster way of cutting grooves into the barrel. The way a button works, as opposed to the broach cutter, which actually cuts pieces out as it goes into the barrel, the button is just pressed into the barrel and then pressed out, and it leaves these dents basically in the barrel. So it didn't require cutting, it didn't have to be sharpened, stuff like that. The mandrel. The mandrel is an interesting way of doing it. The mandrel is a positive form of what you want the inside of the barrel to look like. So you can imagine it like a screw. And then the barrel is put around it, and it's hammered down until it takes on the shape on the inside of that screw piece, of that mandrel. One thing to note, very important for us as forensic investigators, is that every single rifled barrel is unique, and you can link bullets back to the rifled barrel. All right? Oh, my coworkers are laughing at me. It's okay. I can handle that. Looking through a comparison microscope. So I mentioned that the markings on a bullet are going to be unique depending on the barrel that it came out of. When you look down a comparison microscope, it's got two different light paths. It shows you on one side what your test bullet is, so a bullet that you fired to compare to, and the other side a bullet that you got at the crime scene. It's important to note that you can't look at a bullet and then look at the inside of a barrel and see if they match up. You actually have to put another bullet in that barrel and fire it and then compare two bullets. It's the only way it's going to work for you. If these striations, if these lines match up like they do in this diagram, it means that both bullets were fired from the same barrel. If they don't match up, it means they were fired from a different barrel. As I said, this is a diagram, so it's not an actual look at how it really looks. For that, boom, here's a picture. See this line running right down the middle here? All right, that line is the two different light paths on the comparison microscope. So this is one bullet over here, and this is another bullet over here. And they're both being adjusted until you can see if the striations line up, and you're looking under a microscope. Once the striations line up, you've proven that they both came from the exact same gun, which is true for this one. These two match. Some things that you got to keep in mind when you're dealing with firearms. There are general patterns, so things that aren't going to make a 100% identification, but are class characteristics, so they apply to a whole group of things. So certain types of firearms may have a certain number of lands and grooves. Right? They may have a certain direction of spiral. These are things that are going to be true. So if you find a bullet and you have nothing to compare it to, you could say, well, I know we're looking for a Smith & Wesson 38 because that's the only thing that has this many lands and grooves in this direction of spiral. Not everything's rifled. Shotguns in particular usually aren't rifled. Muskets aren't rifled. So not all guns have barrels. Shotguns, which I just mentioned, the way you can determine way you can characterize them is you look at how the pellets came out of the gun, how much they actually spread out. So you can't, it's not as good as if you're working with an actual rifled gun, but you can still say, all right, most likely this damage was caused by this shotgun. And shotguns, lastly, they use the gauge system instead of the caliber system. The way the caliber works, caliber is in hundredths of an inch. Yeah, it'd be hundredths of an inch. So a .45 caliber cartridge is 0.45 inches in diameter. A 50 caliber cartridge is 0.5 inches in diameter. A 38 caliber cartridge is 0.38 inches in diameter. The gauge system goes the other way. The bigger the numbers get, the smaller it is. I'm not sure exactly how many inches it works out to, but like a 12 gauge is going to be smaller than a 10 gauge, which is going to be smaller than an 8 gauge. A 14 gauge is going to be smaller than a 12 gauge. So the bigger the number, the smaller the diameter of the bore is for the gauge system. Speaking of shotguns, here's a shotgun cartridge, and here's how it works. You've got a cap and primer at the back, very similar to the cartridge case we were looking at. Then you've got the propellant and the powder, very similar too. You need something to push the shot out of there. This one's using a monowad, which is usually made out of plastic, and it's just a piece that's meant to push the shot out. It could also be, you know, cotton balled up something, anything that's going to push this stuff out. The shot is a bunch of individual little lead balls or bismuth balls, or I guess it could be steel or anything else. Shotguns were designed initially for shooting at birds. So the idea was there's a lot of shot that comes out, it makes a really wide pattern in the sky, and only 2 or 3 pieces of shot actually have to hit a duck or wing a duck in order for it to fall out of the air, or a goose or whatever people were shooting at. Then at the top you got the crimp, which just holds everything together. And this comes in a cartridge case. Not everything is birdshot. This can be packed with any type of payload somebody cares to put in there. Other ones you should probably know, buckshot is usually just a couple of larger steel balls in here, or larger lead balls in here. There are exotic ones. There's flares that people put in there sometimes, or flechettes, which are like little darts that are used on crazy anti-personnel cartridges and things like that, right? But by far the most common gauge, by the way, for a shotgun is 12 gauge. Okay, so if you're analyzing cartridge casings, which you folks are going to be doing in a little bit, some things you got to remember. The firing pin is probably going to leave a unique mark on the back of the cartridge casing. It may be off center. It may tap it twice for every time the trigger is pulled. It may make a weird pattern, something like that. This is going to be unique for the firearm. Also, as the bullet leaves, as the bullet's pulled out and tossed out, in the case of something semi-automatic, it's gonna, the things that pull it out and toss it out, so the ejector and the extractor are going to leave unique marks as well. And when the breech block pushes up against the back of the cartridge, that's going to leave unique marks as well. So let me show you what these parts are. So here's a labeled diagram for you. You're looking down into the top of a firearm. So if this is a firearm, you'd be looking down here into the top of it right now. This right here is the extractor. So this is the back. This is where the back of the bullet would be. And over here, you've got the chamber. This would be the front of the gun. After the bullet's fired, the extractor is going to grab the back of the bullet and it's going to pull it back here. The ejector is going to bounce the back of the bullet so it goes flying out of the top. And then another bullet is going to be loaded. I keep saying bullet. I should technically be saying cartridge. Another cartridge is going to be loaded up from the bottom and put back here. The bolt face is going to slam it forward. See the hole in the bolt face for the firing pin to go through? I showed you that in a previous slide as well. Just something to note. All right, and I don't know what this is, what this particular handgun is, but you get the idea. Okay, so I was mentioning cartridge casings and all the stuff that can leave marks on them. Let's look at some simple ones. Let's look at some firing pin marks. So if you look at firing pin marks on these 2 bullets here, you're looking at the back of, on these 2 cartridges, you're looking at the back of the cartridge casing right here, which could be left at a crime scene. And you'll notice that it makes a kind of a teardrop shape in this particular case that matches this teardrop shape here. You'll notice how much metal hangs over the edges around here, and it's pretty close to how much metal hangs over the edges here. This would be a match. Okay? If you look at this one, right? Interesting stuff going on here. It looks like it hit once here, and then it bounced and it hit again here. Same thing. It hits and it bounced and it hit again here. I don't know which one it hit first and which one it hit second, but that kind of bouncing pattern would allow you to link these 2 cartridges. Cartridges also have a lot of stuff written on them. It's called the head stamp. So this one says 45 auto RP at the top. It'll usually tell you what the caliber is, what the manufacturer is, and what type of gun it's designed for. All right, that looks like the end of my slides.
That's all, folks.